Hi class, so today we're going to be going through lesson 5, which is x-intercepts and word problems. Less word problems, more solving equations. So your homework for this lesson is posted right here. I'll post the textbook pages on Google Class. It's going to be page 271 to 274. For number 7, it says to graph. Just use Desmos. Don't bother graphing it. Just use Desmos and check your graph like that. And then you have page 281 to 284, numbers 1 to 3, 4, 5 to 6, ACE, and 13. Okay, so by the end of this lesson, this is what you will know how to do. You'll know how to find zeros of an equation, which are also the x-intercepts. So you'll know, that's what we call, that's another word we just use for zeros. You'll know how to write the equation in what we call x-intercept form, which is y equals x minus x plus r, x plus s. And you'll remember this from our class in our x plus minus. You'll remember this form looks kind of similar to what we were doing when we were factoring, right? And then you're going to be able to convert between the standard form, the vertex form, and the intercept form. So you'll know how to go from vertex form to standard form. You'll know how to go from standard form to x-intercept form, and you'll know how to go from x-intercept form to standard form. Okay? You'll be able to graph parabolas using the x-intercept. So that means that knowing what the x-intercepts are, or knowing what is in standard form, you'll be able to find the x-intercepts. Then you'll be able to find the vertex. From that, you'll be able to find the axis of symmetry, any maximums or minimums, as well as the y-intercept. So before we get started, I like to go through this mini investigation with you. So I've given you the links to Desmos.com here, right? So I was going to have you graph it yourself, but it just makes more sense if you go to Desmos and see what the graph looks like. So let's go to Desmos, put this into our Desmos calculator and see what the graph looks like. So I'm just going to go open up my Desmos. I've already put it in, right? So I put in y equals 2x minus 3 squared minus 8. So it looks something like this. And the one thing I want us to note here is these points. So where x-intercepts, right? So it's 1 and 0 and 5 and 0. So those are the zeros of your graph, right? Just want to take those into consideration. That's something we want to have put to the side for ourselves later. The other thing I want us to notice right here is our maximum, our minimum is 3, negative 8. And we'll go over what we're going to do with this information after. But first things first, it says step 2, so that's all it asks you to do, it just asks you to graph. Then it's going to say, okay, step 2 is convert y equals 2x minus 3 squared minus 8 to standard form. So we're going to convert this to standard form the same way that we did in our first couple of lessons. So we're going to do 2. We know that this is x minus 3 squared, so it's going to become 2x minus 3 times x minus 3, right? Not x squared minus 3 squared. So then that's what it looks like. Then I'm going to expand out. So I always like to do my 2 binomials. You can do it whatever way you feel comfortable doing, but I like to do this. So I'm just going to put that in a different color. So I'm going to leave the 2 alone. So I'm just going to do whatever's inside my pink bracket. So I'm going to do x times x plus x times negative 3. Right, negative 3 times x, and then negative 3 times negative 3, plus negative 3 times negative 3, which is, I'm just going to write it down so that we can put it in after. Negative 3, negative 3, close my bracket, minus 8. Okay, so let's just deal with whatever's in the pink bracket first. So I'm just going to write my 2 again. So x times x is x squared, times negative 3 times x is just minus 3. Negative 3 times x is minus 3. And then negative 3 times negative 3 is positive 9. Minus 8. I'm going to go and collect my like terms. So it's going to be y equals 2 x squared. Negative 3 minus 3 is going to be negative 6 x plus 9 minus 8 on the outside again. Now I need to distribute that 2 in. So I'm going to multiply everything inside that bracket by 2. So it becomes 2x squared 2 times negative 6 is going to be negative 12x. 2 times 9 is going to be, I'm sorry, I didn't give myself enough room to draw in the arrows, so it looks kind of messy. And then I have that minus 8 left over. So now I'm going to collect my like terms there. So I'm left with 2x squared minus 12. 18 minus 8 is going to be plus 10. So that's what my equation is in standard form. So it says your answer for your previous question should be 2x squared minus 12 plus 10, which is what we got. And we're now going to find the x-intercept. So now what we're looking for is when the y is equal to 0. Where does that point cross on the x-intercepts? You already did this, right? We've kind of already been doing this. You did this with our last unit. I'm just going to show you a different way, almost a faster way to do this. So what you're going to do, we're going to follow steps 1 to 4. You don't need to put it on a separate piece of paper. I'm just going to do it on the same one. If you want more paper, that's fine. That's up to you. But step 1 says set y to 0. So let's do that. Because at the x-intercept, the y value is 0. So let's make y equal 0. So the entire equation is going to look like this. 2x squared minus 12x plus 10. Because we're looking for the x-intercept. So now it says factor the right side of the equation. So we're going to go here and we're going to be like, okay, this is the right side of the equation. So that's the one we're going to factor. You can't factor 0 anyway, so I don't understand why you would try doing that. Right? And when we're factoring, you need to remember that you need to find r and s, like I have written down here. So how do you find r and s? If you remember back from when we were factoring, r times s is going to give us our c value, which in this situation is going to be, we'll talk about how to do that. And then our r plus s is going to give us our b value. Before we can do that, the first thing we need to do is find a common factor. So if we look here, if you look at the x squared, it has a 2, 12, and 10. So a common factor here could be, right, 2. So let's take out the 2 from everything. So 2 equals x squared minus 6x. I'm just dividing everything by 2 plus 5. Okay? Then once we're done that, what we can do is we can say, okay, now our r times s is going to give us c, which is 5, right, that last term. And then our r plus s is going to give us negative 6. Notice how your r value here is, your c value here is positive and your b value is negative. If you go back and look at our chart, that indicates that we have 2 negative numbers that we need to multiply together to get our r times s. Right? So that means r and s are going to be 2 negative numbers. So let's find all negative numbers that will give us 5. And there's only one possibility. It's negative 1 times 5. Right? And let's do that. Negative 1 plus negative 5 is going to give me negative 6. So it works out. So that means that my r value is negative 5. My s value is negative 1. So if I go in here, I'm going to do 0, 2, x plus r, which is just plus, which is minus 1. And then x minus 1. And that's my factored form there. Okay? Then what we're going to do is we're going to be doing this, something that we call a, oops, I kind of jumped ahead of the curve here and wrote down my answers. What we're going to be doing is this zero product property, right? So if you go here, it says a zero product property states that if a product of 2 numbers is 0, then at least one of the numbers must be 0. For example, if you're multiplying a by b, right, and you get 0, that means that either a and b are both 0, because 0 times 0 will give you 0, or a is 0 and b is some random number, or b is 0 and a is some random number. Because regardless of what happens, when you multiply a number by 0, it becomes 0. And that logically makes sense, right? If you ever have 2 numbers and you know that your answer is 0, right, you must know that either a or b, one of those 2 numbers has to be 0, right? we can actually use this to solve for x in examples where they're given to you in standard form. So when we were looking at x-intercepts before, we were looking at x-intercepts using our vertex form. It was way easier to isolate for x that way. In this situation, you have this x squared and this x, and that makes it almost impossible for us to isolate for x. You can't do it. So what you need to do instead is follow the following steps. So I'm going to show you how to do this, right? And what the steps are, and then we're going to go back and try it again for the other one. Okay? So when you're given something like this, step 1 is always going to be find common factor. So I'm going to go in, I'm going to say, okay, what's the common factor? And our common factor here is 2, right? Because I can divide this by 2, I can divide this by 2, I can divide this by 2. So I'm going to factor out 2. And this is just from lesson 3. 2x squared divided by 2 minus 4x divided by 2 minus 6 divided by 2, right? So let's do that. 2 divided by 2. 0 equals 2. X squared. 4 divided by 2, I'm left over with 2x. 6 divided by 2 is just 3. Right, so I'm left with x squared minus 2x minus 3. Right? Now, I'm going to go and I'm going to factor this inside portion. That's what I'm looking for. Right? I want to know what on the inside of these brackets. So I'm just going to go highlight it in pink. I'm going to try factoring that. Right? So let's do that. We know when we factor, we're looking for r times s. And I always like to make these tables. If you can see it right off the bat, that's fine. That's okay with you. I like to make the table. And then r plus s is going to give us b, which is negative 2. So let's do the math. So I have negative 3, right, and negative 2. If I have a negative product, I know that I'm going to have one negative, one positive number, right? So let's see. Negative 1 times 3 could be an option, or 1 times negative 3 could be an option. Let's see what that gives us here. 1 plus 3 is going to give me positive 2, so I know that's not it. Let's see if the next one is. 1 plus negative 3 is going to be negative 2, so I know that my r must be negative 3, and my s must be positive 1. And it could be the opposite way. You can write s as positive, negative 3 and r as positive 1. It doesn't matter how you interchange those. Now that I know that, I'm going to go back and look at my formula, and I'm going to say, okay, x plus r, x plus s, right? And I'm just going to put my numbers in. So I'm going to do, okay, 0, 2, x plus negative 3. I'm just going to put it in as minus 3. And then x plus positive 1 is just x plus 1. Right? So that's my factored form. Now that I have my factored form, this is what I'm going to do next. Right? So find the common factor. Step 2 is factor trinomial. Okay? Step 3 is going to be use my product, zero product, to find, I'm just going to move this to the side. So step 3 is going to be step 3, right? Use zero product property. So I'm just going to call it ZPP. So what I'm going to do is I'm going to say, okay, 0, 0 equals, I'm just copying it from the other side. And I'm going to take my 2 brackets and I'm going to say, okay, this one, I'm going to make it equal to 0. Just make the entire bracket equal to 0. Same thing on the other side. Make the entire, just the bracket by itself, equal to 0. And now solve for x. Use ZPP. Make each bracket equal 0. Okay? And then step 4, solve for x. So let's solve for x on both the green and the orange. So x equals 0. I'm just going to move the x to the other side. So it's going to be, the 3 to the other side. So it's going to become positive 3. And then same thing here. X plus 1 equals 0. Plus 1 minus 1. X equals negative 1. So those are my intercepts. And then step 5, write the coordinates. So then it's going to be as negative 3, 0, negative 1, 0. That's what we'll do when we do the next one, so you don't worry about it for now, but those are our x's. So now let's try it ourselves. Let's take the factor form of the equation that we found in part B. So we did that. We found it. It's 2x minus 5. And then x minus 1. Right? So let's go write that in. And then let's use the zero sum property to do that. Right? So I'm going to just rewrite it here. 0 equals 2, x minus 1, x minus 5. Right? Let's break up each bracket. So I'm going to do one in orange, one in green. Right, so let's do our orange one. X minus 1 equals 0. So then x minus 1 plus 1 equals 0 plus 1. And then x equals 1. Right? Same thing on the other side. X minus 5 equals 0. X minus 5 plus 5 equals 0 plus 5. These two cancel. So then x is equal to plus 5. So now I have my two x's, right? My two x-intercepts, that means, is when y is equal to 0, x is 1 or 5. So I have two x-intercepts, which makes sense because a parabola will hit that point at 2 points. So then the x-intercepts are, and since it's x, the number is always first, and 5, 0. Which, if we go back and we look at our graph, makes sense. This is where our 0 was. I'm just going to zoom in. This is where our 0 was, right? If we had it. Sorry. I just need to go find my 0. There it is. This is where my 0 was, right? Which is 1 and 0, which is one of our x-intercepts. And then my second 0 was 5. 5 and 0. Which makes sense. That's where my two zeros were. So that's exactly what I found. Okay? So take a minute, pause the video here, try to go through the next one by yourself, just using the same method that we did before, right? And then try to solve that one. And then we're going to go through, I think I actually show you how to do, so you're going to solve it by yourself, find the x-intercepts, and then what we're going to do after is I'm going to show you how to graph using those x-intercepts, right? Because knowing those x-intercepts, you can actually find the axis of symmetry, you can find the maximum from the axis of symmetry, and then we already have the y-intercept, and we can graph it that way. So this is just another way to graph, because vertex form is really easy to graph with. With standard form, there's a little bit more work that's involved with graphing, okay? So pause the video, try to do it by yourself, and then we'll go from there. So let's find the x-intercepts here. Hopefully you pause the video and try it by yourself. If we're going to find the x-intercept here, it's y equals it's 3x squared minus 12x plus 9. So we already know it's going to open upwards because the a is positive, but let's go bit by bit. So let's find the x-intercepts first, okay? So just from the beginning, step 1 is going to be find a common factor. All All right, so I just like to highlight them. So let's find our common factor. Our common factor here is 3. So we're going to pull out the 3. So 0 equals 3. 3x squared divided by 3 minus 12x divided by 3 plus 9 divided by 3, right? 3 divided by 3 is just 3, so it's 0 equals 3. X squared. 12 divided by 3 is 4, left over with the x, plus 9 divided by 3 is just 3. Now we have a simple trinomial in the middle, right? So we can just solve very easily using the R and S stuff that we learned. So I'm just going to make that little chart over here. So I know R times S is going to give me that middle term. Oops. It's going to give me, the last term, which is 3. And then R plus S is going to give me negative 4. So notice how my B term here is negative and my C term is positive. That means that I must have two negative numbers multiplying together, which makes this really easy to work with because the only option I have is negative 3 times negative 1, which if we add those together will give me negative 4. So that means that my R must be negative 1 and my S must be negative 3, right? So let's go put those in. So let's write it in as 3x plus R x plus S. 0 equals 3. X plus minus 1. So it's just going to become minus 1. X minus 3. Now, after we find that, so this was just, because I'm so used to doing this so seamlessly, I forget to write in my steps, but I'm going to write in my step, don't worry. So then step 2 is factor trinomial in bracket. So we got that. And then step 3 is going to be use ZPP, set all brackets to 0. So everything's going to equal 0. So each individual bracket. So I'm just going to go in and write my answer again. 0 equals 3, x minus 1, x minus 3. So we have x minus 1 equals 0. Equals 0, right? Then solve. So step 4 is solve for x. So let's solve for x's. So let's do x minus 1 equals 0. So to get rid of the 1, I'm going to plus 1 on both sides. This is going to cancel, so I'm left with x plus 1, which is just 1. Right, same thing, let's do on the other side. X minus 3 plus 3, right, to get rid of that, 0 plus 3. So x is equal to 3. So I have two x's here. And then step 5 is going to be state x-intercepts. And the thing that you always use, or like the form that you always use, is always going to be x and 0. X and 0. So let's write that in. So our x, the first one is 1 and 0. And then our next one is 3 and 0. And if you wanted to check this, you could honestly just go put in your, let's go to Desmos and let's put in our equation here. So I have y equals 3x squared, right, minus 12 x plus 9, right? And if I look at it, the zeros of my graph are going to be 1 and 3. which makes sense. It's 1 and 3, right? So it says, we are now going to use the intercepts you found above to draw a graph. So I already showed you what the graph will look like, but we are going to draw one. I'll show you how to draw one as well. So what you're going to do is you're going to plot the x-intercept on a graph piece of paper, right? So let's go down here. I'm going to plot them here. I already know what my numbers are, so I'm going to draw my graph in the way that my numbers make sense to me. I just go up by tens, and I can tell you right now that it works. So just trust me. So yeah, we're going to do that. Sorry, give me 1 second. Just got to get my numbers working here. The pencil seems to stop working. Okay, so let's go in here and say, all right, let's draw in our line. And then let's draw in our second line going the other way. So I'm just going to go and draw it from here. Okay. So let's do that. And then I'm just going to draw in my values. Spoiler alert, like I already know what they are. So naturally, so let's do 1, 2, 3, 4. So I'm just going to go -1, -2, -3. That's as much as we need. All right, so let's go put in our x-intercepts. So I know my x-intercepts just from the first equation are going to be, or from the top one over there, are 1 and 0, and 3 and 0. So let's put them in, and I'll use, for both of my x-intercepts, I'm just going to use this green, right, so that we can see them clearly on the graph. So let's go in here. 1 and 0 is going to be right here, and then 3 and 0 is going to be right here. And that's all I'm putting in for now. Okay? So I'm done that. Then it says plot the x-intercepts on the piece of graph paper. Did that. Find the axis of symmetry. So remember that the axis of symmetry is going to be x is equal to h, right? So that's our h value. And then remember that the axis of symmetry goes through the vertex, and it's the halfway point between the x-intercepts. So when you look at the x-intercepts, when you're looking at a parabola, the intercepts actually fold over on each other. And the axis of symmetry is that halfway point. That's why it's called axis of symmetry. So what we can actually do is we can take our two x-intercepts. So we can take our x1 and our x2 over here, and we can add them together and divide by 2 to get our axis of symmetry. So another equation for the axis of symmetry is xr plus s divided by 2. So if you take your two intercept values, take them and then divide it by 2, that'll give you your axis of symmetry. So let's do this. Right? So I know that my r value here is going to be 1. My s is going to be 3. So let's do that. So my h value is going to be 1 plus 3 divided by 2, which is going to be 2 divided by 2, which is just, 4 divided by 2. I can't math today. And then that's going to be 2. So h is equal to 2, right? So that means that my axis of symmetry is going to go along the 2 line. So it'll look something like this. That also means that my maximum has to be at x equals 2, right? So in order to find the vertex, what you do is you actually take your h value, right? So to find vertex, sub x equals 2 into y equals 3x squared into the equation. So let's do that. So let's do y equals 3x squared minus 12x into the original always. Y, oops, y equals 3, 2 squared minus 12, 2 plus 9. Just doing the math. 12 times 2. Always do exponents first. Y equals 3 times 4 is 12 minus 24 plus 9. 12 minus 24 is negative 12 plus 9. All of that adds up to negative 3. So that means at x equals 2, y is negative 3. Therefore, the vertex is 2 and negative 3. So let's go in and do that. 2, negative 3. So now we have our vertex in here. And then it says, the last thing you need to do is find the y-intercept. And that actually tells us what the y-intercept is from in standard form. It's actually 0c, right? So let's go see if we can find our c value here. It's 9, right? So our x-intercept is 0, 9. So I'm just going to go plug that in. 0, 9 right there. Now I have something that I can make a curve with. So let's do that. So I know it's going to start off here. It's going to go through this point to there. Then it's going to turn around and come back up like that. And that's what my graph looks like. That's how you can graph in standard form. That is the way to do it, right? First things first, you got to find your x's. Then you use your x's to find the axis of symmetry. Using the axis of symmetry, you go and find your y value for that axis of symmetry. That becomes your vertex. And then you can just find the y-intercept from the standard form equation, and then you get your graph. Okay? So that's how you do it. It's quite a process, which is why when we graph, we prefer to use vertex form, but you do need to know how to do both. Cool? All right. So it's going to ask us to find the zeros of this relationship. So this is just asking us for the x-intercepts, right? And then we're going to move on and we're going to talk about how to use this to actually solve problems. So I'm going to have you do these by yourself. Pause the video, go through them by yourself, and then come back and watch this. Oops, because we've kind of already been going through this. So you should know how to do them, right? So pause the video here. Try to do those questions all on your own. There's 3 of them, right? And then when we come back, we'll take them up and move on to the next part. Okay, so hopefully you paused the video and you went through them, right? Let's do these together. So, easy. This is already in factored form for us, so we just need to find the zeros by making each bracket equal 0. So let's go in and do that. So one's going to be x plus 2 equals 0. And the other one is going to be x minus 2 equals 0. And we can actually get rid of the bracket part. X minus 2 equals 0. Right? So let's do x plus 2 minus 2 equals 0 minus 2. So x is equal to negative 2. Same thing here. X minus 2, and then to get rid of it, we're going to add 2 to both sides. So x equals 2. So the zeros of this quadratic relationship are, therefore, and just always write your therefore statement with them in the way that they should be, negative 2 and 0. And the x is always going to be the first one, so, and then 2 and 0. They're always going to be written in format x, 0. Okay, so let's go here. Let's find these ones. Again, already factored for us. Sweet. Let's just go in. The negative 2 we can just leave alone, right? And then we have x plus 5. Technically, you should change this y to a 0, right? In a separate step, but I'm not going to do that right now. It's plus 1. Oops. Let's do this in orange for consistency's sake. And then equals 0 equals 0, right? X plus 5 minus 5 minus 5, x equals minus 5. X plus 1 minus 1 equals 0 minus 1, right? So let's just do minus 1 on this side. So that cancels, so we're left with x. 0 minus 1 is just negative 1. That's our answer there. So therefore, our intercepts are negative 5 and 0, and negative 1 and 0. Last but not least, this is a little bit more complicated, right? But not really. We just need to remember that 4x is also in a bracket. So we have 4x equals 0, right? That bracket. And then we have our other one over here, which is x minus 4 is equal to 0, and then it becomes easier. So I'm just going to change this to green. So then 4x, in order to get rid of that, we're just going to divide both sides by 4, and then 0 divided by 4 is just still 0. So x is equal to 0, and then on this side, we're going to do x minus 4 plus 4 equals 0 plus 4, so x is equal to 4. Therefore, our x-intercepts are 0, 0, and 4, 0. Okay? So there are 3 different types of equations for a parabola. We learned vertex form in quad 2 in the first time that we did quadratics in our last unit. And in this one, we've learned standard form, right? And we've learned intercept form, which is what we just learned today. Just as a recall, the axis of symmetry is a vertical line, the vertical line, that passes through the vertex of the parabola. It is a halfway between the x-intercepts, and we can say that x is equal to h. The equation that the intercepts, the roots or the zeros, we call them either. So I can say, find me the x-intercepts, find me the roots of this equation, find me the zeros of the equation. They all mean the same thing. Can be read as, is known as the intercept or root form, or sometimes we even call it the x-intercept form. It has a general equation of y equals a x minus r, x minus s, where r and s are the x-intercepts. When you're given an equation in this intercept form, in order to find the vertex, what you need to do is you need to take r, you need to take s, right? And what you're going to do is you're going to add them together and divide by 2. So to do this, find the mean of the two numbers, add the numbers, and divide the sum by 2. The axis of symmetry goes to this point and is written as x equals h, where h is equal to r plus s divided by 2. Take this x value, substitute it into the equation, and solve for y, and that'll give you your vertex. So that'll give you h and k. And remember that the vertex can either be a maximum if a is negative, and then a positive a will give you a minimum. So let's go through, this is just the steps that I've already taught you, right? But we're going to go through them one more time so that you can see them in action. So first things first, let's look at this graph and we're going to say, okay, we have negative 2x squared, right, plus 4x plus 6. Does this relationship have a maximum or a minimum? And explain. So I'm going to go, in order to find out if something has a maximum or minimum, I always look at the a value. Right, so let's look at our a value. Our a value in this situation is negative, which means it will have a maximum. It will have a maximum. The graph opens down. Down, since the a is negative. Therefore, it is a maximum. Right? That makes sense. If you had a graph, I'm just going to show you a rough sketch. If you had a graph and it opened downwards, there's going to be a maximum. If it opens upwards, there's going to be a minimum number. Okay? That's from unit 2. So then it says find the roots or the zeros or the x-intercepts. All of those words interchangeable. Okay, just know what they mean. So in order to get the x-intercept, we have to factor, right? So factor, first things first, common factor, right? So find out, can I get a common factor out from there? Which I can, because there's a 2, or a negative 2 rather. So negative 2x squared plus 4x plus 6. So let's pull out the negative 2, right? So that means everything on the inside is going to be divided by negative 2. So y equals negative 2. Let's do negative 2x squared divided by negative 2. I'm just going to zoom in so you can see. Plus 4x divided by negative 2. That's important because that's going to change the sign. 6 divided by negative 2. Because it's a negative, you know it's going to change the sign. So just be mindful of that. And then I'm left with y equals negative 2. Negative 2 divided by negative 2 is going to be positive x squared. Positive 4 divided by negative 2 is going to be negative 2x. And see, that's why the sign changes. And then positive 6 divided by negative 2 is going to be negative 3. Okay? Now that I have this, I'm going to use my R and S stuff in order to find what the inside terms are going to be. So I'm just going to, I like to highlight this in pink and just go, okay, now I'm just dealing with the pink portion. I'm leaving the 2 alone. Right, so let's just deal with the pink portion. So I know R times S is equal to C, which in this situation is negative 3. R plus S is equal to negative 2. Right, and if I know that one is negative and one is positive, both of them are negative, it means that I'm going to have a positive and a negative. So let's think about it. I can do 1 times negative 3. I can do 3 times negative 1, right? And those are the only 2 options I really have. So let's do this together. So if I have 1 plus negative 3, I get negative 2. I don't need to go any further. I got my answer. So my R and S values must be R equals 1, S equals negative 3, right? So then I'm just going to write that in. Negative 2, x plus 1, x minus 3, right? And then I'm going to use my 0 product property, and I'm going to say, okay, so x plus 1 equals 0, right? And then x minus 3 equals 0. So let's go and find x equals plus 1 minus 1 on both sides. X equals negative 1. And then I'm going to get rid of the 3 over here. Whatever I do to one side, I got to do the other. So x equals positive 3, right? So I have those 2. That means that my intercepts are going to be, therefore my intercepts are going to be 3 and 0 and negative 1 and 0. I'm just going to take my 2 values. Then I'm going to say, okay, I want to find the axis of symmetry, right? So h is equal to my 2 0 values. So my 3 and my negative 1. So R plus S divided by 2, right? So I'm going to take my negative 1, my positive 3, divide that by 2. I'm left with negative 1 plus 3 is just 2, divided by 2. H is equal to 1. Therefore, at vertex, x is equal to 1. That's the axis of symmetry. So in order to find my maximum or minimum, very simple, I'm going to plug in h equals 1 as x equals 1 for y at maximum, right? Because we said at the beginning we had a max. So let's go plug it into the original formula. Y equals, and use the original formula. Don't use your factored form. Because even if you made a mistake, right, you're using the one that has the least room for error. I'm just solving. 1 squared is 1 plus 4. Oops, this should be plus. Then we do negative 2 times 1 is negative 2. 4 times 1 is just 4 plus 6. And then if we do that, negative 2 plus 4 is negative 2 plus 4 is 2 plus 6 is 8. So my y value is going to be 8. Therefore, my vertex is going to be HK, which is my H was 1, my K is 8, right? Or HY in this situation. Y, it's going to be 1 and 6. Therefore, vertex is 1 and 8. Not 1 and 6, sorry. So vertex is 1 and 8. So now it says, write the relation in vertex form. Easy peasy. We know what our A value is. It's negative 2. That didn't change. Our H value is the axis of symmetry, which is 1. Our K value is a max, which is 8. So if I wanted to actually write this as maximum is 8. That's because that's what the question was asking. So maximum is 8. We got that. Now we just need to go plug in our numbers into y equals a x minus h squared plus k. So let's do that. Y equals negative 2 x minus 1 squared plus a. And that is my answer. So that's how you go from standard form to vertex form. It is a real big ordeal, yes, but that's how you would translate between the two of them. Okay, and that's it for this lesson. And you can either use this to graph, or you can use the way that we used up here, which was you can find the y-intercept and graph it that way. Okay, and that's it. That's lesson 5. See you later.